Only hope to tell me why you don't wanna agree.
I told me other lies. It's only a you out to fight. It's only a you out's goodbye. I just can't heal, can't fight.
Only hope I wanted you
Hi, good morning, good evening, good afternoon. This is Mike from Unknown Tech, and welcome to episode 27 of the Architect Podcast. So today is August 1st. I can't believe it's August already. I hope you guys are having a great summer so far. Today we're going to be talking about a specific subject, and I'm not going to get off on a tangent like I usually do. And we're really going to focus on Nutanix Acropolis Hypervisor 11.2, which was just released, and the functionality of what we call topology awareness in the hypervisor for AI use cases and for specific platforms, by the way. And we'll talk about some of those platforms. But what is the goal of this, right? The goal is really about providing a solution that allows enterprise customers and even neo cloud providers to leverage the platform, the infrastructure that they have, the accelerated compute, the networking, all that capability, right, at the most optimal way. Okay, so generally it's tackling a couple different things. Okay, so the very first thing is when enterprise or neo clouds buy these platforms, so say it's an HGX or MGX platform, okay, there's a lot of components within the platform that have to operate, right? You know, we always hear Jensen from NVIDIA talk about extreme co-design. Okay. And so what he means by that is obviously every piece and component within the AI platform integrates and interacts, right? Meaning that one can't be the bottleneck for the other component, right? There has to be extreme co-design, meaning that whatever's required for the GPU, right? The networking can't be the bottleneck, the storage can't be the bottleneck, etc. I hope that makes sense. And so what I'm saying is when you buy these platforms, they have CPUs, of course, they have memory, system memory, they have GPUs, right? They have DPUs, and they have high speed east-west networking. Could be DPUs, could be CX7, CX8, etc. NICs. Could be InfiniBand, right? For optimal, right, and massive throughput, 800 gigabit networking, right? Very, very fast, very, very robust from a throughput perspective for east-west traffic. And then generally speaking, 400 gigabit or gigabit, in DPU, as well as DPU offload, right, for network services and those things for north-south traffic, right? That's your storage traffic. That is your management traffic, et cetera. And so the question then becomes is, how do I optimally use this platform for the multiple use cases for AI within my enterprise? Because you're not going to buy this platform. And by the way, we're very early on in the stages, and you've heard me talk about this before. Let me just level set what's happening. So, I had the distinct responsibility and in where I work at Nutanix, no secret, right? To talk to prospects and customers in the enterprise and to understand what it is they're doing with cloud native and AI, right? So we're just focused on really AI today. Cloud native is part of this, and we'll talk about that, but let's focus on the AI subject. So when I talked to customers last year about what we call enterprise AI, and you've heard me talk about this before if you watched my previous podcast, I don't mean AI that's just running on-prem. I mean AI that is controlled and governed, right? And, used in a hybrid fashion, right? So you're going to have AI services that you're going to consume from the hyperscaler. You're going to have AI services that you're going to consume from frontier providers like Anthropic, as an example, OpenAI. And now there's these new use cases of bringing, repatriating some of that intelligence back on-prem, specifically to control token costs, data locality, data governance, IP protection, right? Intellectual property protection, competitive protection, right? All of those things. And so now you have this kind of hybrid solution. Well, how do you control all of that? How do you govern all of that? And how do you make sure that you have a single point of consumption, right? And governance and observability That's what enterprise AI is. Okay. And that's what Nutanix is delivering with the Nutanix Enterprise AI or agentic AI platform. Okay. And so going back to what I was talking about, the on-prem, the repatriation of intelligence is obviously requiring customers to procure new and different hardware stacks that they typically don't purchase. Okay. And so there's basically two or three things happening in the data center that's fundamentally changing infrastructure, right, within the enterprise landscape. The first thing is these platforms require differences, right, than steady state workloads. So typically enterprise infrastructure is used to, okay, I have my proprietary platforms for things like maybe Cisco UCS, and not Cisco UCS, but UCM Call Manager. Even that's changing now, right? That's not as proprietary as it used to be. And I have my core platforms, right? Server platforms that are my virtualization stack. They have my databases. They have my VMs, my core server, my core foundational services. All that runs in a virtualization environment, right? And those servers are generally heavy compute, CPU, memory, high speed storage, right? And whether you're running HCI or external storage, that's besides the point. The point I'm making is that's generally speaking what the stack looks like in the enterprise. Now, there are some enterprises I talk to that have machine learning stacks, right? Not proprietary, but customized high performance or HPC stacks for machine learning. And they're using things like Slurm and those types of solutions, right? To do those, to provide those capabilities. What I'm talking about is the transition of every server, every platform into an accelerated platform. That's what's going to happen in the next decade, right? Every platform is going to have XPUs within the platform. It's going to require high speed networking, probably customized networking, InfiniBand, et cetera, right? And it's going to be running different protocols, all using Kubernetes, okay? All using advanced acceleration technologies like SRIOV, RDMA over fabrics or RDMA over Ethernet, right? All of those things are going to be required. Okay. Now, what is missing from that stack? What's missing from that stack is to optimally run efficiently for multiple use cases, okay, within that stack. Because Kubernetes, the default scheduler, is not NUMA aware or PCI-e device aware. And you're probably thinking, why is that important? Well, NUMA awareness is important. If you're a virtualization engineer or you're an infrastructure engineer, you know about NUMA awareness. You understand that the CPU is provided to your virtualized workloads, right? You want that the memory stack to be fed from the same memory channels, right? Connecting to the CPUs that you've assigned to that VM. That gives you the shortest path to memory, right? So you get low latency, high throughput, et cetera. Now, that's part of it. And then when you look at the PCI devices, right, those are also aligned to the CPUs. Okay, so you may have PCI device 0 through 3, right, which are 4 slots, right, which are connecting to a PCIe switch, which then connect to the CPU, right? That's specific CPU. So if you have 2 CPUs, you may have PCI slots 0 through 4 that may have 2 switches, PCI switches, or 1 PCI switch connecting to CPU 0. And then you have PCI slots 4 through 7, okay, that connect to CPU 2, right? And within those PCIe slots, you have GPUs, you have CX NICs, PCIe NICs, and you have DPUs. Okay. And so when you deploy on Baremetal Kubernetes, it has no concept of any of that. It has no concept of NUMA awareness, has no concept of PCI route mapping to CPU, right? And because of that, we found that you're going to lose about 33.6% on average of efficiency within the platform. That's a lot of loss for how expensive these platforms are. So when I'm buying a, $500,000 platform, right, for AI that has these GPUs, et cetera, okay, and I'm losing 33% efficiency, or let's just say 30 plus percent efficiency on the platform, I'm throwing money away, aren't I? And so that is the problem that topology awareness solves, right, when it comes to the proper scheduling. And I'm going to get a little bit deeper into this, and I'm going to show you in different ways, okay, what I'm talking about. So you've all seen this before. Let me share my screen. Oh, and before I move on so if you want to go to the YouTube and stream versus LinkedIn, you can actually go to this link here. So I'll give you a second to click on this link or copy this link and go there. I found that YouTube has a better quality from a streaming perspective. Okay. So let's go ahead and share. I'm going to share my screen here. Okay. So just quickly, you've seen this before. If you watched my podcast previously, this is basically the 5-layer cake, right, that we look at, right? This piece right here, right? From a AI platform perspective, okay? And at the bottom here, we're really going to focus on this layer here, okay? The accelerated compute layer. And, of course, you have your accelerated compute, you have your data services and storage, you have your container orchestration, which is Kubernetes, and you have your AI platform services. And then, of course, you have your control plane, right, to kind of deliver all of that. And so we are really going to be focused on this. However, it does tie into this a little bit. We'll show you what that looks like. But we're really going to focus on this area here. How do we segment this to run efficiently? And because we're using a hypervisor, how do we make sure that you're not losing bare metal performance? Meaning, how do we get bare metal performance out of the hypervisor? And we've accomplished that with topology or hypervisor. I'm going to show you the numbers. Okay. So let's, just framing the conversation. Let me delete this really quick. Let me get out of here. And we're going to just jump into this right here. So let's assume, right? And by the way, these are platforms that you guys are going to start, the enterprise is going to start adopting. Today, what we're seeing in the enterprise, for the most part, some enterprises have these platforms, not saying they don't. For the most part, we're seeing a lot of enterprises start to dabble into enterprise AI, and they're really purchasing and acquiring entry-level platforms, okay? And what I mean by that is they are more PCIe based, right? Add-in card platforms. So think of NVIDIA, the Blackwell Server Pro, right? And if you look at that, right, you have all these vendors that provide a version of the Blackwell Server Pro. AMD has their own version, right, with the Instinct GPUs that are add-in cards, okay? And really the popular add-in card we see today from an entry-level perspective is the RTX 6000 Pro Blackwell Enterprise Edition, okay? And the reason why that is because it provides the most bang for buck when it comes to, entry-level inference, et cetera. Because customers, like I said, are just starting out. And that's okay when it comes to small amount of users, right? And you can scale those. I'm not saying you can't scale those platforms and give it high bandwidth. The problem with those platforms is they're not really built for the scale of agents and what's going to happen with agentic AI, right? Because in the large enterprise, you're going to scale from 5-10 agents. I was just talking to customers the other day at an event. Some had 3-4 active agents in production. That's generally what I see, right? Between 5 and 10 agents in production, right? Now there's many being tested. There could be 100 agents being tested, but in POC, but in production, there's 5-10 agents. Eventually it's going to get to thousands of agents. Okay. And because of that, it's going to require a platform that can scale to that level. And so you're not going to continue to buy more than likely. You may, depending on the use case, but more than likely you're not going to continue to buy the RTX Pro 6000 base servers. Those are very, very entry level. Okay. And I know you're thinking to yourself, well, geez, Mike, I can buy a server with 8 of them in there. That's expensive. It's not, doesn't sound entry level to me. And I have a lot of memory there. I get it, but understand that your bandwidth between GPUs internode in the server, or excuse me, intranode within the server is very, very low. You're going across PCIe bandwidth. So if you require larger memory for larger models, as an example, right? Or for different use cases, maybe you need 2 GPUs for a specific use case. The GPU to GPU bandwidth is based on PCIe 5, which I believe is only 32 or 36 gigabytes. I have to double check. Whereas if I use NVLink, right, in this platform that you're looking at here, or maybe I'm using H200 NVLs with NVLink, right, I can get upwards of 900 gigabytes of throughput GPU to GPU. That's a massive difference, right? That's a massive difference in inferencing capabilities. Okay, especially when it comes to scaling agents, training your own models, right? Batch inference, all of those things. Okay, so let's look at this platform here. So this is a platform. It has B200 GPUs. It actually has, in this case, I'm showing 4 GPUs, right? And you can see here you have CPU memory, you have a PCI Gen 6 switch, right? You have the B200 GPUs associated with that PCI Gen switch 1 on the left, and then you have 2 B200 GPUs associated with the PCI 6 Gen switch on the right. And then that PCI Gen 6 switch also connects to ConnectX 8 NICs on the back for each CPU, right? And so what happens today is when you use Kubernetes, right, and you create your pod on Baremetal, what happens is you could assign CPU and get CPU from the CPU 1, but the memory will be on CPU 2. So you lose lack of NUMA awareness. And your GPU that you assign, yeah, it could be on CPU 1, but the NICs are on CPU 2 on PCIe Gen 6 switch 2. So it's not aligned in a nice device group, which we call it, which aligns to that CPU and that PCIe switch. And because of that, you're losing massive efficiency and performance. And by the way, you're causing, or you could cause, noisy neighbor issues between multiple use cases within the platform. Kubernetes by itself, right, the default scheduler is not NUMA aware or PCIe switch aware or NIC mapping to root domain or GPU mapping to the CPU root domain from a PCIe perspective. That doesn't have that capability today. Okay. And so what we did is we layered in optimal placement with adding a hypervisor. And the first thing people say is, well, you're adding a hypervisor, you're not going to, you're going to lose performance just by doing that. And that's wrong. The way we've done this, okay, the way we've provided optimal placement, right? The work that we did behind the scenes on AHV to make it topology aware. And we did this in partnership with NVIDIA, by the way, in this use case. Okay. So we thank them, of course, right, for the partnership. But also the work we've done in Acropolis Hypervisor, right, to map the device groups. What I mean by device groups is it will automatically map the right NIC, the right GPUs to the right PCIe switch to the right CPU, and you get memory NUMA awareness on that memory, those memory channels for that CPU. Okay. And so at the end of the day, what you're doing is you're creating a node, right, VM within the hypervisor. You can see here there's VM1 I just created, and it's automatically created this device group, right? So say I needed a B200, all right, it's going to map the ConnectX 8 NIC to that B200, to that switch, that PCIe Gen 6 switch, to the CPU, to the memory, okay? And now you have complete topology awareness with optimal placement. And so now that VM1 is now a Kubernetes node, right, that you can bring to bear into your Kubernetes layer. And it will be topology aware. So think of this like you would take this, right, because these are your GPUs, your GPU infrastructure. They would be you're basically building your node pools for your accelerated compute. All right. And that's what we're doing here, but we're doing it at a VM level. And like I said, there's always this argument about bare metal versus virtualized. That argument is moot now. because I'm going to show you here in a little bit the performance that we're getting versus bare metal. Okay. Secondly, and we can map this out, right? So we create another node pool that has VM2, right? It maps it. I create another node pool, VM3, it maps it, VM4, et cetera. You guys see what I'm talking about here, right? So the idea here is to get optimal placement of NIC, GPU, PCI switch, Gen 6 switch to the CPU, with CPU has NUMA awareness, all right? That way you're not going across the CPU interconnect, right, to access memory on CPU 2 if your VM has CPUs that are given from CPU 1. All right. So let me get out of this really quick. That kind of gives you an idea of what I'm talking about. Now, that's kind of a logical view of this. I really want to get into more of a what does this look like in real life, right? So if you watch my other podcasts on the Nutanix AI solution blueprint and the NVIDIA storage reference design with Nutanix, you'll see that it maps out a couple different types of platforms as examples, right? And I talked to you guys too about, the NVIDIA kind of nomenclature. That's what this is here, right? This configuration overview and how they come up with these numbers, right? So in this platform, for example, it's the NVIDIA 285-200 configuration. And what that means is the first number is 2 CPUs. The second number is how many GPUs? There's 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. Right? The third number is how many NICs are in the system, right? 1, 2, 3, 4, 5. Okay. So you have 5 NICs. And what is the bandwidth of the ports on the NIC? 200 gigabyte, right? You can see that here, 200 gigabyte. So that's why you had the 285 configuration. Now, it goes back to what I was talking about, though. If I were to lay down this environment as a single Kubernetes node, right? Then I create my pods from that. It has no clue about the NUMA awareness, right? So if I say, okay, this node has, lays down on this, so I have the whole thing. Then I start creating my pods and I start passing through. Well, if I assign, right, if the system assigns CPU from CPU 0 or 1, it gets memory from CPU 2 or 1, whatever you want to call it. This is CPU 0, this is CPU 1 over to the right. Okay. And then I say, okay, I want to pass through GPUs, right? I want to pass through 2 GPUs to this. It takes a GPU here and here. Well, that's not optimal placement, because look what has to happen for GPU connectivity, right? Not in the same NVLink domain at all. So now I have to traverse the PCIe bus, right, to actually communicate between GPU to GPU. That's bad, right? That's not allowing me optimal bandwidth, right? When I can get up to 900 gigabytes, I don't know what it is for this particular model, but just assume that NVLink today can give you up to 900 gigabytes, I think, on the GB300 Blackwells, I think. I'm not sure what the H200 NVL. You can do 2 by 2, right? You can connect 2 cards together. You can do it, which is basically a 2-finger card, or you can do a 4-finger card to connect all 4 GPUs, right? And again, the idea here is to make sure that the GPUs stay within the same NVLink domain. So when I create this pod, I want the GPUs to come out and say it's 2 GPUs. I want that to connect to these 2 GPUs over this NVLink domain to get this throughput between the GPUs. I want to use system memory from this CPU because I'm getting CPUs from this, so I don't want this anymore, right? And I want NIC connectivity to come through this NIC here on the same PCIe switch. right? Because now I have complete control, right? And complete awareness from a topology perspective into that CPU. Now you're probably asking, okay, Mike, I understand that, but what does that really gain me? Okay. So the first thing it gains is multiple use cases hitting one platform. So if Joe needs to do a batch inference job, right? And he requires 4 GPUs, as an example, that these 4 GPUs are delivered either from this right-hand side, all of them, or this left-hand side. So let's assume it's the right-hand side over this NVLink domain, okay? Using these 2 NICs, okay? Connecting to these 2 PCIe switches to this CPU and using this system memory, all right? So say that batch job, right, requires that CPU from here, memory from here, four GPUs over this single NVLink connectivity, okay? That's going to be by standalone, right? That's going to be a standalone node pool, as an example, okay? And say Jenny comes in and says, well, I have a marketing campaign that I need to run, and my agent runs this marketing campaign, and it requires 2 GPUs, right? Which will go through this PCI switch. It'll hit this, it requires CPU from here, and it'll use this memory. So that'll be a node pool. Now, because we've separated this, what have we done? Right? There's nothing shared being used between the two, right? So the first thing is true multi-tenant. I can't draw. Multi-tenant. Okay. And no noisy neighbor. Okay. So now you have true separation and no noisy neighbor issues to contend with, right? And let's just say you have a chatbot that requires 2 GPUs, right? Here's a chatbot. This is use case 3. That requires 2 GPUs, and those I should use different colors. And it uses these, right? This GPU, this NIC. Oh, I forgot to add the NIC there. This PCIe switch up to the CPU, up to the system memory. Okay. None of those are going to impact the other. Okay, because it's physically separated from a topology mapping perspective. Okay. And so I have node pool 1 here, node pool, I don't know why I picked red. Let me go back. This is node pool as well, right? So maybe this is node pool 1, this is node pool 2, this is node pool 3. And now I'm servicing 3 different use cases, right, on the same platform. Okay, this is what's going to happen within enterprise AI as you expand your intelligence, as you grow your intelligence within your environment. You're going to require the ability to leverage your platform optimally. Hopefully, you're using 90% of this, right? That's the hope. I want this to run at 90%, right? So I get the maximum efficiency and the maximum token output for all of these use cases. That's the goal, right? And then, of course, the idea here later on, right, on our roadmap is to be able to bring in these node pools, stand them up for specific jobs. So say it's a batch inference job. Well, if it's batch inference, it'll run it during a specific time frame, and it'll stop. And then because it stops, right, it tears this node pool down, and then brings it back to the pool of resources that you can consume to create a new capabilities, right? That's the idea here. We don't want GPUs to be communicating outside of their NVLink domain. We don't want the NICs to be outside of the PCIe, the same PCI switch domain as the GPUs that you're using. We don't want the memory to be outside of the CPU domain, right, of the specific CPU you're using. All right, that's the whole idea of it. Now you're probably asking, okay, Mike, what does that give me? Well, let's talk about that. The second thing is performance. So because this is virtualized, and by the way, this is part of it. There's basically multiple things that give you the performance that's bare metal performance. It's obviously offload. So there's a lot of offload technologies here. Okay. You have offload tech, SR, IOV, right? RDMA, etc. So you have that piece of it. There's also AHV innovations that we've done around delivering bare metal performance as well. But then if you look at the PCI device mapping, right, and the optimizations there, you're getting bare metal performance. You're getting, so for example, on this 400 gig, you're going to get 400 gig. You're going to get port speed on this. Okay. In bare metal, if it's not part of the same PCI switch domain, and say you're servicing over here, but these GPUs, right, you're losing 33% efficiency. Okay, you're not getting that performance. Okay, and that's a problem, right? That's the idea of. I don't know if I can't. Excuse me, I may have misspoke. This might be 36%. I have to double check. But the reality is, you're using 30+% efficiency by not doing the topology mapping. Okay, that, like I said, this is big because these platforms are not cheap, and this is one of the cheaper ones. Okay, if you go down here, let's get out of here. If you go down, all right, we start getting into the HGX platforms with the baseboard, right? You start getting into these, you're talking, more money, right? And so you're spending more money. Is there another bigger one here? This is the Grace Hopper, right? You're spending more money. You want to spend money on these platforms because these platforms have high bandwidth memory, right? They have HBM memory. So one of the differences between the RTX Pro's Blackwell 6000 as an example, that uses GDDR7. This uses HBM3, I believe, or HBM4. Very, very high bandwidth. You see here I was talking about NV switch 900 gigabytes a second, GPU to GPU bandwidth. If I don't use NV switch, I'm bound to PCI Gen 5 bandwidth. That's like 32 or 36 gigabytes of throughput versus 900 gigabytes over NV switch. That's crazy, right? That's how much you're losing if you don't stay within that domain. Okay. So let's go back to, I just want to go back to this presentation really quick. So topology awareness for non-uniform memory access NUMA. So increased speed and decreased latency between GPU and network, right? So instead of, using an inefficient, right, mapping, right, what we do is we create, for lack of a better term, device groups. And the device group will automatically, when you create the profile, and I'm going to show you what that looks like, it'll automatically map the NIC, the CPU RAM, NUMA boundary, and the GPU on the same PCIe switch to that optimized node pool VM, right? That's what we're talking about here. So we increase speed and decrease latency between CPU and network. I'm going to show you what that looks like. We do PCI switch optimization, so schedule GPU and network for PCI switch topology awareness. So in this case, right, this is your switch topology right here. And an optimized VM here will use the same PCIe switch topology, right, and map those devices together for that we say a VM. It is a VM, but really it's going to be a node, a Kubernetes node, right, that you deploy in a node pool for your GPU your accelerated compute use cases. And a new network offload devices, so CX7, CX8, even the Intel X810 is supported. Okay. Okay. So this is some of the preliminary testing. So don't take this as gospel yet, but this is some of the preliminary testing when we enable topology awareness, right, within the platform. HGX, H200, B200, B300 at bare metal performance with cloud, with Nutanix Cloud Simplicity, right? So virtualize matches, bare metal, right? Using nickel, right? 2.19.3 It's apples to apples from a bandwidth perspective, right? So you can see this. You're basically getting line rate, right? We're basically within the bare metal, right? So 100.3%, 101.0% of bare metal within run-to-run noise. Why it matters? 2.6x bandwidth penalty if it's not topology aware. So when you correct the GPU NIC pairing, right, you get to 99.1% of like a 400 gigabyte line rate. Non-optimal, I'm sorry, it was 38%. I was wrong. You lose 38%. So placement, not the silicon, decides the difference. Everybody's like, oh, I have 400 gigabit NICs, right? CX7 NICs on my platform, or NVIDIA Bluefield DPUs on my platform. You're not getting that line rate unless you do this topology awareness. Okay. So again, turns your solution into a multi-tenant solution, right? 1 8 GPU node packs 1 times 8, 2 by 4, 4 by 2, or 8 times 1 GPU VMs. Zero manual tuning. When you create the profile, which I'm going to show you, it automatically uses device groups and does the mapping. So it does hardware discovery, does NUMA alignment, topology aware placement, NV switch partitioning, PCI-e injection, and north-south wiring are all automatic. Near bare metal speed, right? So full GPU pass-through NVLink full mesh up to 900 gigabytes, GPU to GPU on H200 as our test showed, and GPU direct RDMA at line rate, no measurable degradation versus bare metal. So your storage, your GPU direct, GPU to GPU, right? No measurable degradation. And you get cloud-like manageability, right? So bare metal performance delivered as VMs, the flexibility enterprise and neo cloud providers need to run multiple teams and customers on the same hardware. True multi-tenancy, delivering optimal efficiency at bare metal performance. Okay, so that's why we have introduced topology aware Acropolis hypervisor. Okay. There was one more thing I wanted to show here. Just bear with me a second. Oh, let's show the demo. So this is our interface we call Prism Central. Within Prism Central, we have this new hamburger menu, right, under Compute Profiles. These profiles is what you create. So you create a profile, and that profile automatically maps the device grouping of the CPU memory NUMA awareness, GPU NIC requirement that you're creating for the profile, right? And then mapping that to the PCIe switch associated with that CPU. Okay. So here we'll go through what it looks like a little bit. So we're going to update. We're going to show you an update to a profile. So when you go in here and you go into update, this is 2 B200s, 24 cores, right? 2 CX7 NICs, 24 cores of CPU, 400 something gigs of memory, right? We enable virtual functions, right? That's SRIOV. And now you can deploy it. So now we're going to deploy this. All right. So we select a project. So projects, think of projects as like our multi-tenancy feature. We pick the cluster. We clone the image. This is the Node OS image for this VM, right? In this case, we're using the Ubuntu image. And then we hit deploy. Or excuse me, we attach a subnet to that, of course. Obviously, we need a subnet for the networking. And then we hit deploy. And it creates the virtual machine on the back end. And that virtual machine you can see here is deployed in the list of VMs. And now that can be used as a VM, right, for Kubernetes from a node pool perspective. And that node pool now would be part of your Kubernetes platform. In our case, we use NKP, but you can use any Kubernetes platform to leverage this. And then you get that full mapping there. Okay. So this is just a demo explanation on AHV topology awareness. I hope you see the value in this. As you start thinking about deploying some of these higher end, right, scalable solutions for your agentic use cases, right? Because this is typically where we are today, right? We're here, right? We're in this. We're in a combination of these things, I say, but this right here is what's growing fast, right? Multi-agent, they're long-lived, right? It does require a combination of CPU and GPU. Don't get me wrong, right? Agents are not all about GPU acceleration, right? The reasoning process, that part of it is GPU, but a lot of it's CPU is, calls, right, for serial communication, for tool calling and things like that. So, high core count, low power, high core count CPUs. NVIDIA released their latest Veris CPU, right, based on ARM architecture. AMD's releasing, I think it just talked about their AI event, the Venice CPU architecture, which is coming. Very, very efficient, right? Many cores. And that's what's going to be required for multiple agents. But as far as the platform perspective is concerned, when it comes to the accelerated compute, in order to take advantage of this, right, this platform that you invest in, you want to use as much of it as possible and generate as much tokens as possible, right? The more autonomy, the more tokens, which requires more infrastructure. Okay. And so the bottom line is you want to bleed as much capability out of the investment that you have. And this is what topology aware Acropolis hypervisor will provide you. Okay. So this was a short one this week. I hope you have a great rest of the weekend and a very productive week ahead. I look forward to talking about more subjects coming up. I'm going to take a break for probably a week and be back the following week, depending on where I'm at. Actually, I may not be. It may be a few weeks before I'm back. I do have a lot of travel. We have our sales kickoff coming up. So I may not be back on for another podcast for the next at least 2 to 3 weeks. And we'll pick up where we left off when it comes to agents and agentic harness. And we'll talk more about what Nutanix is delivering there from that perspective and some of the best practices around that. And like I said, I hope you have a great rest of the weekend and a very productive week ahead. Have a good one.